two things to start off the day with. One is, please note on the board, it says that our second test on reasoning will be a week from today on day 17. That's all the stuff we've been learning in the past 2 weeks, right? So please consider how the last test went for you and what tools and processes you employed to get yourself ready and how you might want to adjust that for this time. 1 week from today. Now, the other thing is, if you are an iPhone user and you have discovered iOS 17, I guess, is the new one. You may have discovered that the notes feature we've been using to create PDFs doesn't work anymore. So I want to show you a new way to do it. Okay, take out your iPhones, please, if you have them. Watch, please, as I go through this process. So first, I'm going to select photos, and I should have already taken pictures of some things. And I'm going to press select up here to select a few photos that I want to put together into a PDF. Bottom left-hand corner is a share button. I press that. And then I move down here to print. And I'm going to print this series of photos, but I'm not really going to print it. Watch what I'm going to do. This is like a preview area where I've got the pictures. And what I'm going to do is I'm going to zoom in. I'm going to go down to one of the pictures and pinch out. This now creates a document that's in a PDF format. And in the bottom left-hand corner, if I now share it, I should be able to go to my Canvas app and put it where I want it to go.
Mr. Erlin,
yes.
I have iOS 17, but I can still scan them.
Well, I had a number of students say they couldn't. So I researched and found another way to do it. You can use either way that works. Okay, any questions? All right. All right. Does this look familiar to you? It's an algebra expression, right? An equation with two expressions set equal to each other. How would you go about solving this? Loudly for me, Carter. Tell me. Pick one thing. Okay. Do you guys agree? Minus 3x. And when I do it over here, I've just changed the balance of power. So I have to do it over here, right? That's a rule we've learned. And I'm left with 5 is equal to 9x minus 15. Then what? Violet? Add 15, sure. And if I do it to one side, I have to keep it balanced by doing it to the other side. Then what? Divide by 9 because it's being multiplied by 9 now. I don't want 9x's, I want just 1. So I'll undo what's being done to x. And I get this crazy looking fraction. Let's just leave it as an improper fraction for now. Am I done? It doesn't look right, does it? Wouldn't you rather write it like this? Doesn't that seem more right? It's kind of like the difference between big red balloon and red big balloon. Doesn't one of those sound right and the other one not sound right? Okay. This is algebra. In the world of geometry, we're going to do some of these things again. Bless you. But we're not going to write these little notations in there. We're not going to put minus 3x, minus 3x. Instead, what we're going to do is we're going to have you write what it was that you did to get from this step to the next step. This first step will always be given. How did you get from here to here? What did we do to both sides? We subtracted 3x. And we did it to both sides to retain the equality. So since we subtracted, it's called the subtraction property of equality. That's what got us to here. And then we chose to do something to get us to the next step. What did we do in the next step? We added, and did we do it to both sides to retain the equality? So what do you think we call this one? Good. Addition, property of equality. And then to go to the next step, divided by 9, which means what did we do? Division, what? Property of equality. Now, what about this step? My guess is nobody knows why we're allowed to do this, what the name of the rule is. Well, if you remember back on the first day in geometry, I told you that I wanted to clear your brains of any remnants geometry knowledge and give you nice, clean, accurate, aligned knowledge. So we all have the same material in our heads, but that I needed you to retain your algebra knowledge. Well, what exactly did I ask you to retain? I haven't told you yet. So today we're going to work with properties of equality and properties of congruence. And they're as simple as we just saw. Notice here, if I've got an if and a then, what kind of statement am I working with? Conditional. In other words, I'm establishing some parameters to begin with, and then I'm introducing an impact. If I began with A equals B, and I end up with A plus C equals B plus C, what did I do to both sides? I added the C, which means the reason I did that was the addition property of equality. Okay, you guys are filling these notes in as well. What about the second one? Subtraction property of equality, because we're doing it to both sides, right? Second. Thanks. See if you can do the third and the fourth ones, please, while I take attendance. Easy peasy, right? What's the third one? Count of three. 1, 2, 3. Good. Fourth one. 1, 2, 3. Very good. Why do you think it says C is not equal to 0 here? Because you can't divide by 0. So we can make it division as long as C isn't 0. Very good. Now, this next one is probably unfamiliar to you. Anyone know this one? Yeah, like why would we? It's just there. It's hard to come up with a reason for it, but actually there is a reason for it. It's called the reflexive property of equality. These last couple ones are new to you. Those first ones you were familiar with in concept. What about this? If A equals B, then B equals A. And now you're not allowed to say, well, duh. This one's called the symmetric. There's symmetry, balance, Symmetric property of equality. What about the next one? A equals B and B equals C. Then A equals C. It's kind of like the law of syllogism that we did, right? A logic chain. But in this case, we're going to call it transitive property of equality. What do you think of when you hear the word transit?
Bus.
Yes, a bus. So if you get on a bus in town A and you take it to town B, and then you get on the bus in town B and take it to town C, didn't you really go from town A to town C? Yeah, that's the way I like to think of it. And the order does matter. Versus this one. If you have A equals B, then B can replace A in any expression. So for example, can you combine these two things and say something? What can you say? A equals 3, good. Why? Is this transitive? It's not, because you're getting on in town A and you're going to town B, and then you're getting on in town 3 and going to town B. That's not going to get you there. You're ending up at B twice. So this would be substitution, where you say, I'm going to pick this up and substitute it in for B. Does it turn out the same? It does. But the trick is, substitution is a property that we've created, we've built, that works in the world of equality. We can use it in the equals world. But we can't use substitution in the inequality world. Like if you had x is less than 3, you wouldn't be able to use it there. But with transitive, you would be able to. Let's move over here to the right where it says properties of congruence. What's the difference between this and this?
One's a point, one's a line segment.
I agree that this one is a line segment. Is this one a point? No. A single letter would be a point. But what does it mean when I put two single capital letters next to each other? It's the distance between them, the measure of their length. It's a single dimension of measurement. Like if I had two sparkling water drinks, if I take the two cans and I try to add them together, do they make magically a larger can? No, objects don't combine together. But if I took the volume of one can, 12 fluid ounces, and the volume of another can, would those add together? They would. The world of equality versus the world of congruence. That's what today's lesson is primarily about. Well, one of the three things. So in this case, when I've got both sides exactly the same, but instead of it being an equal sign in between, it's a congruent sign, what do you think we're going to call that? Reflexive what? Good. Reflexive property of congruence. Okay, what about the second one for the congruence? If segment AB is congruent to segment, there was one on your desk, did you not? Chair over there, please. Stool top. AB is congruent to CD and CD is congruent. Oh, then CD is congruent to AB. What do we call it when we switch them back and forth? Yep. Symmetric what? Good. Property of congruence. You got to pay attention to whether it's equality or congruence because it'll change the name. Last one. What is it? Good. Transitive what? Transitive property of congruence. So which one has more, the properties of equality, the properties of congruence? Many more properties of equality. There's more we can do with the world of equality. There's only a few rules we get to use in congruence, so it's going to be harder to work in the world of congruence. What about this last one we didn't fill in? What do you call that? Good. This is the distributive property. I personally don't call it a property of equality per se, because you're not doing it to both sides of an equation, but it does retain the equality. So it's arguable. If you want to put equality, that's okay. If you want to leave that off for that one, it's okay. Now, flip over here, and you'll see that what I've done is I've put together a table where one side are things that have to do with congruence. The object of segment AB, the object of triangle ABC, the object of angle A, those all belong with this symbol called congruence. Whereas on the other hand, the right side, thank you. Yes, it's the right side has different information. This is the word of congruence on left, equality on the right. So here we're talking about the length of AB, or the measure of that segment. We can also do, remember what this is called? What are we adding here? Good. This is called the segment addition postulate. And because, like I talked about with the can, you can add the fluid ounces of one can to the fluid ounces of another, and it creates a volume that's equivalent to both. We get to do equations on the equal side, plus, times, minus, divide. We get to use numbers. Anytime you use any of these things, it's orange. It's part of the equality world. So what today's activity for this page is you're trying to decide if these are written correctly. If all the parts are yellow, in other words, they're from the congruent side, then it's valid. If all the parts are orange, in other words, from the equals world, then they're valid. But if it's a blend of both of them, that's an invalid expression. We have to fix it. So what about AB? With nothing on top of it, is that orange or yellow? AB with nothing on top of it. Orange, okay? What about the equal sign? Orange. What about numbers? Orange. It's a match, right? All three are orange. So do we call this valid or invalid? This is valid. Therefore, we don't have to correct it. What about the second one? Is AB orange or yellow? Orange, plus sign. BC, equal sign. AC, valid or invalid? Valid. Okay, let's skip down to this one. AB is congruent to 8. AB without a line on top, orange or yellow? Orange. Congruence. Yellow. Uh-oh. Right there, I know I'm what? Invalid. And let's just finish it out. What's 8, orange or yellow? Orange. So I can either fix this by turning theoretically both of these into yellow. Is that possible for this problem? I mean, I could turn this one into yellow, putting a line over it. Can I turn a number into something for the congruence world? No. So I got to fix this by changing the yellow one. What should this be written as? Equals, right? I got to swap out the congruent sign to make it equals. Then it's a valid way to write it. What about the next one? Please take a look at it. Decide if it's valid or invalid. If invalid, how would you fix it? All right. Did we decide valid or invalid? Count of three. 1, 2, 3. Invalid. Good. Can I get someone to raise their hand, please, and tell me how you fixed it? Yeah.
I split a regular equal sign.
Good. You left them all in the equals world, changing the congruent sign to an equal sign. Would it have been okay also to put the bars over the top? In other words, could I have said AB plus BC is congruent to AC? No, because the plus sign, right? Addition is only an equal world. You can't do it in the world of equality, of congruence. Okay, this will be part of your homework. Tuck that off to the side for a second. And let me give you the second sheet. What do you notice about what's up on the screen? Does that look like dramatically new stuff or a lot like what we just did? Pretty much the same thing. But this time we're going to apply it in a form of proof. You guys ever heard about geometry and proofs? Nobody? Usually people have this sense of, oh, geometry is so hard because of the proofs. Today we're going to start with that. I think you'll come out with an idea that they're not. Okay, bye. All right. So you should try to do these from your own head. But if you need to reference what we just did, you could do that. These are all properties of equality. And if I want to express the addition property of equality, if what, then what? If A equals B, then that's not the addition property of equality. What would we need to do to both sides to express the addition property of equality? Add something. So like we could say A plus C equals B plus C. What about down here for the symmetric property? Remember what that one said? Symmetry, back and forth. I could choose A and B again, or I could say like if AB is equal to BC, then what? BC is equal to AB. Reflexive is another new one. For any real number A is equal to A. What about the transitive property? What do you think of when you hear transitive?
It must be, no, AB equals BC.
If AB equals BC and good, BC equals something else, maybe CD. AB equals CD, good. Then it's like a train run all the way to the end. So what you're going to do is you're going to fill in these properties. Again, you can use what we did a moment ago to fill them in. And then you're going to write the property for each one. Like what would number 3 be? 10y equals 10y. Both sides are exactly the same. Good, reflexive. And what kind of sign is between them? Equals or congruence? So property of equality. What about number 8? If 10x plus w equals 41 and w equals 1, then 10x plus 1 equals 41. Good. Substitution. Property of equality.
What spell out property of quality from the text, or we can just do like prop equal.
I'm okay with prop equal. I'm okay with POE, property of equality. I'm okay with writing it all out. The trick is when you shortcut, make sure you don't choose something that's ambiguous, like substitution and subtraction. So you can't write sub prop equals. That would be confusing. But otherwise, yes, you may truncate. Okay, please go to the second page. We are going to be doing algebraic proofs today. And there's many forms of proof that we're going to go through, ways to prove something is true. Today, we're doing something called a two-column proof. A two-column proof simply means that you've got two columns. On the left side, we've got these things called statements. The statements or steps are listed on the left side. And the reasons justifying each statement are listed on the right side. The challenge in geometry in general for you will be twofold. One is eventually you'll be creating these steps in the right order to achieve a goal. And then you're going to have to justify each step. And you'll need to learn what possible reasons you can put here. Like you could never write, well, because. It's not a good reason. Because my neighbor told me so. Not a good reason. But what you can use is any property like the ones we've just written out. You can use any theorem. We haven't done many theorems yet. We've done a couple of postulates, like the segment addition postulate and definition. And it's always going to be given that the first one is given to you. So you can write given. Those are the only 5 things you can use as reasons. Let's go down and do number 3 together. Notice here that this looks like algebra, doesn't it? You're given something that looks like an algebra equation. But the difference is I give you the answer. And this is the way I do homework too, isn't it? I give you the problems, but I give you the answer. In other words, I want you to get to this answer by showing me how you get there. Show me your work. So how do I get from step 1 to step 2? Very good. So we write that as a reason. Distributive property. How do I get from step 2 to step 3? I'm going to subtract 27 from both sides. And instead of writing it underneath like we did in algebra, I'm just going to come over here and say, if you don't know how I got to there, let me tell you. I'm going to use the subtraction property of equality. And number 4? Good. And we don't just say division, we say, good, division property of equality. All right, you are going to finish this whole sheet in a few minutes, but would you please do number 4 right now? Everyone do number 4, and let's check in on that.
Then I would be, when you're giving me a two, look into this block and over, like, wait, the map.
Yeah. That's the new one, isn't it? What do you guys call that? Symmetric. Because we're retaining the equality. Property of equality. All right. So here's what we've got for the rest of today. Got a big chunk of time. You're going to finish these packets, a total of what, 5 sheets, 5 sides, and you're going to submit those in Canvas. You'll then have a good solid half hour of unstructured time. We're wrapping up this grading period, aren't we? Grades are closing down. The grading period ends this Friday. We'll get grades next week. So use that half an hour for something that's appropriate. In my class, if you failed my first test, remember I've got a way that you can bring it up to a 70%. If you got like a 70 or 73 or 75, you can't bring your grade up, but you still may want to do my activity to repair your understanding so you're in better position. It's an online version of a test. You can take it as many times as you want. Each time it gives you immediate feedback if you're right or wrong, and I'll only keep your best scores. And if you can get up to an 85% on that today in class without working with another student, without using notes, just doing it yourself, then I'll raise your overall grade up to a 70%. Okay, this ensures that everybody has the ability to keep going in the course without hitting a wall early on. All right, so work on this packet, please. And if you want to talk to me about remediating Unit 1, we can do that.